friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn some other properties of tangents. What do you mean by a tangent and what are the basic properties of tangents we have already learned in the previous videos. There are some more properties pertaining to tangents and let us understand those in this video. How many tangents can be drawn to a circle? A tangent is a line which touches the given circle at one point, right? Can I draw any tangent to the circle which passes through the circle? Then it is not said to be a tangent, right? It should touch the circle at one point. If at all I choose a point which lies outside the circle. From this point, how many tangents can be drawn to this circle is the question. How many can be drawn? If at all, we start drawing the tangent. This is 1. Is there any other possibility? Yes, we can draw one more tangent. Are there any more possibilities of drawing tangents to this circle through this point? If at all I try to draw some more lines, those will become secants of the circle or they will be lying outside the circle. So only 2 tangents are possible to be drawn from an exterior point to a circle. Now what does the theorem state? 2 tangents can be drawn to a circle from an external point, then the lengths of the tangents are equal, right? Lengths of the tangents are equal. There are 3 points in this theorem. The first one, lengths of the tangents are equal. Second one, they are equally, they make equal angles at the center or they subtend equal angles at the center. This is the center of the circle. C, P, T, T dash. T is the point of contact of this tangent and the circle. T dash is the point of contact of the second tangent and the circle. Now if at all I draw a radius which joins these 2 points, similarly I can draw one more radius, right? When I say the tangents subtend equal angles at the center, what does it mean? I can always join this external point to the center. Then the tangent subtends angle TCP, the tangent PT subtends the angle TCP at the center. Similarly, the angle subtended by the tangent PT dash is PCT dash. Those 2 are equal is the second part of the statement. Now the third one is they are equally inclined to the line segment joining the external point to the center of the circle. What does it mean? The tangents are equally inclined. That means they make some equal angles. To what? To the line segment joining the center to the external point. This is a line segment joining the center to the external point. And these tangents are equally inclined to that. Means to the line segment joining the center to the external point. We are going to prove one after the other. Now, first one we are going to prove. We know that the radius is perpendicular to the tangent. So this angle is going to be 90 degrees. Right? Just in the previous video we have seen that radius is always perpendicular to the tangent at the point of contact. In the sense, this is a radius which is passing through the point of contact. It is going to be perpendicular to the tangent. The same proof, I can prove that this is also going to be 90 degrees. Now, to prove that, first one, these are to be proved, required to prove. First one, PT is equal to PT dash. This is to be proved. How are we going to prove? Consider 2 triangles we are going to consider. Triangle PTC and triangle PT dash C. These are the 2 triangles I am going to consider. What all are equal? First of all, we are going to consider what all elements of these 2 triangles are equal. First thing, angle PTC is equal to angle PT dash C is equal to 90 degrees. The reason, geometry requires reason at every step wherever it is necessary. Radius is perpendicular to the tangent at the point of contact. Done. Now, PC is equal to PC, which is going to be a common side, right? And TC is equal to T dash C. The reason is they are the radii of the circle. Therefore, triangle PTC is congruent to triangle PT-C by some axiom. In the earlier videos we have learned 4 axioms based on which we can check whether the given pair of triangles are congruent or not, and the 4 axioms were SSS, SAS, AAS and RHS. Which category does this pair of triangles fall under? They are congruent by right angle, hypotenuse, side. So it is going to be RHS axiom. Therefore, these 2 triangles are congruent by RHS axiom. This is what is a basic proof, right? When these 2 triangles are congruent, then the corresponding parts of congruent triangles are equal. This implies if we overlap or superpose one on the other, these 2 triangles are going to be exactly coinciding. That means PT and PT dash should be exactly coinciding. PT is equal to PT dash. CPCT. Corresponding parts of congruent triangles are equal. Done. So these 2 sides are going to be equal. Similarly, these 2 angles are going to be equal, right? When they are going to be superposed on each other, they will be exactly coinciding. That is possible only when these 2 angles are equal. Implies TPC is equal to angle T dash PC, and also PCT is equal to PCT dash. We have proved all the 3 statements at one go. The reason is we have proved that these 2 triangles are congruent. When 2 triangles are congruent, then the corresponding parts of the congruent triangles are equal. So first thing we proved is 2 tangents are equal from an external. When 2 tangents are drawn to a circle from an external point, then the measures of the tangents are equal. PT is equal to PT dash. That is the first thing. Second statement, as I said, they subtend equal angles at the center. What do you mean by subtending equal angles at the center? Angle PCT should be equal to angle PCT dash. We have proved that angle PCT is equal to angle PCT dash. Same reason for all the 3 statements. CPCT, right? And the third statement I told you is they are going to be equally inclined to the line segment joining the center of the circle to the external point. That means angle TPC should be equal to angle T dash PC. Did we prove that? Yes, angle TPC is equal to angle T dash PC, and the reason is same old CPCT. So at one go, with one simple proof, we have proved this entire theorem. This theorem had 3 parts in it, right? All the 3 are proved. Quickly I am going to repeat the statement and then we will move on to the next video. The statement of the theorem is, from an external point, 2 tangents can be drawn to a circle. Then these 2 tangents are going to be equal in measure. They subtend equal angles at the center and they are equally inclined to the line segment joining the center to the external point. We have proved all the 3 using only one simple axiom, that is right angle hypotenuse axiom. To prove RHS axiom, to prove that these 2 triangles are congruent, we have made use of one simple theorem of triangle, that is radius is perpendicular to the tangent at the point of contact. Hence we are done, right? This is a video which will explain the basic theorem of tangent properties. We will move on to the next video where we are going to learn about many more properties like alternate segment theorem, tangent and chord properties. Let's meet in the next video. Thank you.